Alright, this is Ken Roosevelt, and this is Binomial Probability Advanced. It says, this problem is taken from ALEKS. Suppose it is known that a new treatment is successful in curing muscular pain in 55% of cases. So let me first of all identify P, our probability of success, as 0.55, which implies that Q is 0.45. If it is tried on 6 patients, find the probability that at most 3 patients are cured. So that's find the probability that 3 or less patients are cured. Well, the probability of 3 or less is going to be equal to the probability of none, of 1, of 2, and of 3 all being added together. And so you would have to do the binomial probability formula, which says that P of x is equal to, and choose x times P to the x times Q to the n minus x. And we did a video on this, and you go through all that. However, ALEKS has an easier way to do it if you know what you're doing. There is a calculator feature that you can use. So let's go to that. Let's try that out. If you watch the other video, you know how to do it by hand. Let's talk about how to use this. On the calculator, over here we have this button right here, and you can see it's a binomial probability. So let me take it out. Okay, this first box, if you look back here, what's for n? N is always the sample size, so n is 6 patients, so I'm going to put 6 there. And the next box is for P. P is the probability of success, so cures in 55%, so 0.55 goes in that box. And we want to know what the probability that at most 3 patients are cured, so that's less than or equal to 3. So the last box gets less than or equal to 3, and we get equals. And our answer is 0.55848. And they want us to do it to 4 decimal places, so we're going to look at that 4, and then the number after that is an 8, so it's going to be 0.5585 is our answer. And I'm going to hit next. Okay, now I'm going to do another one here. Here it is. A multiple choice exam consists of 8 questions with possible answers A, B, C, and D. So whenever there's 8 or 4 choices, you have a 1 in 4 chance of being right. Find the probability that a student gets at least 2 correct. So when we say at least 2, we mean 2 or more. Now, I'm going to go back here for a second, and I'm going to erase all this. And I want you to think for a second what 2 or more means. If you have 8 questions, let's say you can possibly get none right, 0. You can get 1, you can get 2, 3, 4, 5, 6, 7, or all 8 right. What did they say? They said find the probability that the student gets at least 2. At least 2. I believe that's what it said. Yeah, at least 2 correct. So on my little number line here, which is essentially what I did, I drew, how would we graph at least 2? Well, we would go 2 or more. And I want you to notice, if this was my probability distribution, and here was the line for 2, or actually we'd have to go 1.5, and this is 2.5 if we're doing there. So 2 lies between 1.5 and 2.5. So this little rectangle here represents 2, and it's in those borders. So I'm going to put a little 2 down here. Upper bound, or upper bound, lower bound. Not that that matters. What I want you to see here is that if I had a bunch of more rectangles here, you know, I'm not saying that this is what the distribution looks like, but all of them would be shaded because these are the ones I'm interested in. And the ones I'm not interested in finding are the boxes or rectangles for 1 and 0, which should show the probabilities of those things happening, those events. So now let's go back to here. This is where you can get messed up if you're not paying attention. The probability of 2 or more, then, looking at this picture here, is not a left-hand shading, it's a right-hand shading. So first thing I'm going to have to do is go 1 minus this here. And since the part I want to take out is the white part in the other picture, and it begins at 1, what I need to do then is I need to go, let's see, I have 8 questions, so I put an 8 there. I have a 1 in 4 chance, so I put 0.25 here. And I'm interested in 1 or less, because if I subtract the probability of getting 1 or less right, that'll leave me with the probability of getting 2 or greater. And so that's how I do that. It's 63.291, so I go 0.6329 and I'm done. It's a very handy little device that you can use there. We'll do one more and this will be it. So we're tossing the coin 10 times, find the probability that he gets at most 8 heads. So at most 8 heads means 8 or less. So that one's very easy. When we plug this into the calculator, we get the left-hand side, which is the less side. Okay, and this is 8 or less. So we know this is going to be 8 or less. So it's less than or equal to 8. This is out of 10, and it is heads or tails, so it's a 50-50 shot. And those are the values we put in. And what we get is 0.98926. Alright, if you look at that 5-7, alright, that 5 is going to round up, so this will be a 3. 0.9893 is our answer. And that's it. I hope that helps you use the calculator. We're done.